So good evening. Welcome to our Chemistry in the Community 6th Edition webinar series. This webinar is on Unit 3, which is Petroleum, Making and Breaking Bonds. Our presenters this evening are Barbara Sitzman from Granada Hills Public Charter High School in California, Linda Tilton from Woodlands Academy of the Sacred Heart in Illinois, and I am Michael Murray from the American Chemical Society in D.C. Linda is actually going to be our lead presenter tonight, but I'm going to get us started as we go through. Remember, if you have any questions at all during the webinar, please contact us. And if you have any questions about ChemCom at any time, please contact us as well. You can contact us at chemcom@acs.org. So the opening, here's the opening for Unit 3, which is, again, petroleum breaking and making bonds. In this unit, students are going to learn about how bonds are broken and how bonds are formed and the energetics. They're going to be doing a lot of organic chemistry, building alkanes, alkenes, doing synthesis reactions. Linda's going to go through all of that with us. So the first section, they're really going to talk about what is petroleum, and then in section B, they're going to talk about petroleum as a building material. Section C, petroleum as an energy source, and then looking in section D at alternatives to petroleum. So the unit opener for this unit is actually an advertisement commercial for a car called the TLCP. Using alternative energy, and it's going to introduce students to this alternative energy, and they're going to have to come up with their own commercial for their own car by the end of the unit. So this is showing them what they're going to actually do by the end of the unit. So I'm going to hand this over to Linda right now, and she's going to walk you through the unit. Barbara and I are going to be here, and we will give feedback and other suggestions as we're going through. So I'll turn it over to Linda right now. Thank you very much, Linda.
Well, thank you, Michael, and I want to say welcome to everyone for joining us tonight. Before we actually get into Section A, though, I want to remind you that at the very beginning, in the Teacher's Edition, beginning with Unit 3, Roman numeral II, there are lots of tips. There are lots of ideas for you, planning guide, as well as lists of materials that you'll need for this unit. So as you're going through this unit, don't forget you do have that teacher support there, as well as the materials that are in the margins around the student text. So we're going to begin here with what is petroleum, the focus. As with all of the units, I always begin by having the students read together with me out loud, choosing different students or just myself to read the goals. The kids are quite amazed, and by this time in the year, they're going to have an idea of what those goals mean. And you can get an idea here by looking at the list. This is exactly from the book. And the kids will see some words that they don't really know what they are, and so they do. It is a hook. My students are definitely interested when we take a look at the goals, and then we'll follow up with concept check 1 for this unit. There will be some feedback, and in my classroom we do this out loud. I have the students respond to the questions. I know some teachers use these as a homework and then as a discussion guide. You'll find what works for you in your classroom may change from period to period. But again, a reminder that the students will be able to find, for example, the answers to number 1. They're going to refer back to the commercial that Michael talked about. We're going to go back and take another look at physical properties, and then number 3 and 4 on this page, the students may not have an answer for, but at this time, by this time in the year, they are comfortable not being able to answer that, and you may be surprised that some of the students actually do have answers or ideas. This is a short, very short, 5-10 minute discussion that sort of opens up Section A. And we'll follow up with an investigating matter. A couple of tips that I'm going to offer you, and then I know Barbara probably has some also. This is a really great activity for the kids to get their hands on some examples of petroleum-based materials. You will have to do some prep for this because each of your lab groups will require 5 test tubes pre-prepared by you, as well as an empty culture tube, and you'll find that the culture tubes do work the best if you can get your hands on them. You may also use a test tube with the correct size cork. They don't seem to carry over from year to year, and this is a time-consuming setup, so you will want to be able to store this. I suggest that as you're preparing these, use a glass bead, and if you follow the teacher's manual, there are some really good preparation suggestions. You're going to use a glass bead. You get these at Michael's. If you use plastic, you'll find that they decompose. You will have an opportunity to talk about some new terms, viscosity, resistance to flow, and you're also going to have an opportunity to talk about design of experiments and what are good questions. The students, there are actually 2 parts to this. The first is the test tubes and the beads, and if you have stopwatches, they'll work fine. A lot of kids have devices that have seconds on them, so you can advise them to use their second hand on their watch or in the classroom on their computers. If you can flip to page 270 in the teacher's manual and in the student book, you'll see that they are beginning to talk about, in the table 3.1 at the top, we're beginning to talk about different sizes of molecules. It's just information. It's just information that will add to the base of the student's understanding and hopefully help them to understand in more detail later. You will prepare a model for the students of the empty setup. So and then also provide your class with data for the empty tube mass, data for the mass of the tube itself and the cap, or an average for the cork if you're using a cork, an average of the mass of the beads, because they're going to calculate density. And I have found that it's better for me to prepare that in advance, and also the teacher's guide suggests that you do that, so that you post that on the board or in the, sometimes you could even just write it on the experiment if you're photocopying. And by the way, there are, in the teacher resource materials, there are copies of the labs, so students don't have to take their books to the lab station when they're performing this experiment. I have had excellent results. Students get what I would say is pretty accurate information, and it's pretty much across the board that they get this accurate information. Another thing that I don't think I mentioned is volume. You want to also give them an average volume, so they're going to have that information to work with and to generate data that they will interpret later. The second part of this experiment asks them to calculate some densities for solids. It asks for paraffin wax, and you can get that at the grocery store if you don't already have it. And they just need a small piece chunked up so that it'll fit into a graduated cylinder. And you'll want to make sure that you have the right size piece of wax that'll go into your graduated cylinders so that they can use Archimedes' principle and calculate the volume of that odd-shaped piece of matter. Asphalt, well, that'll be fun for you to collect. I went out when they were laying new asphalt roads and picked up some pieces, hit it with a hammer, and got just perfect size pieces that the students can use and get pretty accurate data. In your teacher's manual, there are also expected results, and these run pretty close to what my students get for this experiment. It's a good way to kick this unit off. Again, it takes a whole lab period, and then we will talk about the kind of evidence they get and what that evidence means. Barb and Michael, do you have any more tips to add for this one?
Well, one thing I do, this is Barbara. Hello, everyone. Where it says motor oil, I sometimes get some different weight motor oils, and their viscosities are a little bit different, and that students find that interesting because they've heard of motor oils of different weights. And I was actually able to get some crude oil. Now, it's kind of pretty nasty stuff. You have to be careful of it, but I've got some sealed in a container, so we do that sort of as a demonstration. After the lab, one of the students holds those up, and then you wait, and you wait and you wait until the bead goes down to the bottom of the crude oil. Other than that, my students are pretty average. Everyone takes chemistry as sophomores or juniors, and we have various different levels of chemistry, but this is the general course that they take. And usually I have to split this up into a couple of days, and I kind of like having students be able to do lab 2 different days instead of just one. So we'll do the viscosity on one day, and that's fairly short, and then we'll have more time for the second part, the density part of the lab. We had an earthquake here quite a number of years ago, and so I got lots of asphalt then.
Good job. Good job. I find it a pretty satisfactory lab. Kids really come away with a good foundation, and they understand it, so I think that's great. Moving into the next section, a source of energy and hydrocarbons. This is a reminder to the students of what it is that we're actually talking about. What are these things? Here I live on the shores of Lake Michigan, and the kids have seen these big ore boats. And so we start to consider what is this petroleum stuff we're talking about in the natural state? What is it? And if you'll think about what are things that are made from petroleum, you can ask the kids to come up with what they think is made from petroleum. At this point, they will have probably not got a clue. But I point out that pretty much everything around the room is petroleum-based. Of course, they think that only gasoline and fuels are petroleum-based. They're going to introduce the word hydrocarbon. And so that's going to add, of course, to your understanding and your working knowledge and vocabulary for this section. Also, we're going to take a look at what what reactions are going to look like. It's on the following page. That is pretty much just sort of an informational foundation for where we're going with what is petroleum in Section A. A3 is origin and distribution of petroleum. Students know about fossil fuels. They have gotten that in elementary school. But it's going to be a reminder again to them of what is a fossil fuel, where does it come from, where is it found, why is it the way it is. You're going to have an opportunity to visit current events, and they have a lovely picture in the textbook of this oil rig, and of course the students that I have now remember the Deepwater Horizon disaster and the oil spill, and they still see the commercials on TV for BP and the coast, the Gulf Coast, as it is for a vacation spot. Again, this is pretty much general information. I do try to pull out of the kids at this point what ideas they have about petroleum. Where is it? Is it everywhere? Where do we get it? You're going to have an opportunity to talk about the Middle East and why the Middle East is so important. Barbara, you got anything to put in on this one?
Well, you know, if any of you live near where there are any of these oil rigs like the one shown, you might check with them, because I was able to get an educator's tour one time where we were helicoptered over and we landed on a rig, and we spent the whole day going up and down the ladders 14 stories high and learning about the different processes. It was fascinating. So I have a PowerPoint that I show my kids of this. And so, you know, you could check. I live in California, so this is off the coast up a little bit north of LA. And they still offer these trips. So if anybody's from California, you might think about that.
Boy, that sounds amazing. I for one, would love that. There's a wonderful map in the textbook that shows where the oil is, where are the reserves, where are the petroleum reserves, where's the population, and what part of the population consumes the oil. This brings in something that I think is so important, and something that sets chemistry in the community apart in getting into the societal issues. And this again brings up everything that is going on in the world with petroleum, and it sort of ties it in for the kids so that it's a little more meaningful. The next section, your carbon footprint. Students are asked to compare and analyze per capita carbon dioxide emissions and population data, and compare their carbon footprint with carbon footprints from students, other students around the globe. Again, they're going to be asked to read a graph and read a table and make connections. This is what we call our developing skills. These are reading questions and responding. I have students do this for homework, and then we talk about it in class. It's maybe 15 minutes of a conversation, but it's, again, making this close to the real world and bringing the real world into chemistry. The next activity is another investigating matter. And this is a simple distillation. The students are asked to distill an unknown solution that could have one of several different components, substances in it: propanol, rubbing alcohol, acetone, water, or cyclohexane. And in my classroom, I'm lucky enough to have computer probes, and so we use probes rather than thermometers to get the data. And the students will distill this unknown solution, and when they read their data and generate a graph, they'll see that the data comes up sort of at a point where it could be one of two of the components, one of two of these substances. And so they will then follow up by testing their distillate on using some different chemical help me chemicals. If they'll add iodine to them, and if it turns magenta, then it could be cyclohexane. If it turns bright yellow, it could be alcohol. Yellow to brown, it could be acetone, and if it's colorless to light yellow, it could be water, and it works perfectly. We will begin then discussing separation techniques for mixtures, and this we will now see throughout the text in further units. There are some diagrams in the textbook, this one right here that you see, and then also other setups, followed by some pretty good questions reflecting on the evidence. At this point, the kids are able to pretty much assemble their lab, perform the lab, and then take it down under supervision. Also, I want to remind you that in the teacher resource materials, there are printouts for this lab and for all the labs, so they don't have to take their textbooks to the lab stations. This requires the kids to be careful, and I always double check all equipment before I let them begin. Make sure that they have all the components connected properly. Rubber tubing is clear, and the cool water is running in the right direction, and so on. Again, I get really good results for this one. Barbara, any?
Well, I might mention we don't have condensers for everyone. We've got one condenser for the class, and so I do it as a demonstration, but the demonstration is an interactive one. A couple of students are assigned the task of assembling the apparatus. Somebody else is keeping track of the temperature. Somebody else is keeping track of the time, and all the students, of course, are recording the data, and then someone else can collect the distillates. And so there are quite a few students actually involved in this. Another thing I do is that they do, as Linda said a moment ago, they test their solutions with iodine. And since their solution is just the propanol and water, then I bring out some acetone and cyclohexane, and students test that too, so that they can see those other colors. They particularly like that magenta that she mentioned a moment ago. Thank you, Linda.
Okay. Again, they're going to create a graph, and then they'll be asked to interpret the graph. They'll have two plateaus in this one. They'll have the plateau where the alcohol boils off, and then they'll have a plateau at the top where the water reaches boiling point. Pretty good activity. Lots of discussion around this one. Petroleum refining, we're going to move into fractional distillation. Isn't that clever? Right after our distilling lab. Lovely picture of the refinery here. Unless you're lucky enough to live along in an area where there are refineries, students may not have any idea, never seen, never heard of refineries, other than once in a while refinery accident. So this is a really good picture. We also have in section A6 a diagram of the fractional distillation, the fractionating tower, and I would say spend some time talking about what happens in the tower. In my classroom, we take it right directly from the lab to what happens in the fractionating tower. There is lots of information in the diagram in the textbook, lots of information that you can use to talk about how these molecules move once they get heated, what difference are there among their boiling points, what happens when something boils, what does it have to do with if something boils at a lower temperature. What does that mean? Well, we've talked about phases earlier in the year. We've talked about the various phases of matter. We've talked about what happens when a molecule or a compound boils. What does it do? It turns into a gas, and gases are generally less dense, so they rise. And this really is a great discussion point. If you don't have a picture to put up on an overhead or using projector, definitely have your students refer to the diagram in the textbook. It also explains in pretty good detail what kind of materials are produced by the distillation of each fraction. What are the products? Something that is of great interest is the fact that petrochemicals are produced from darn near every one of these fractions, and so students begin to wonder, what are these petrochemicals? Barb, do you find this to be pretty satisfactory diagram?
Yes, I do, and I've been to a refinery, but they are locked up now. You have to be vetted before you can go in, and then they wouldn't let us into any of the buildings. The company just simply took us in a van around and pointed out various different things, but it's just for security reasons. They're really tight to see very much of anything that's going on in a refinery.
And I think you're lucky to have gotten in, because I have tried to get in more than once for just a tour, and after 911 they've just totally been locked down. So
right. Well, one of the amazing things that we saw was huge mounds of powdered sulfur, and the kids have seen sulfur. They used that in Unit 1, and that because they removed the sulfur from the crude oil is pretty contaminated that we get off our coast, and there's a lot of junk in there they have to take out. So I tell the kids about this. Yeah. But ChemCom just lends itself to bringing in your experiences, things from the newspaper, from magazine articles. It just lends itself to that.
Absolutely, absolutely. And the kids find this very interesting, and P.S., they never figure out it's organic chemistry till we're further in. Concept check 2, again, they're asked a couple of questions. Where did petroleum's energy originate? How are the components of petroleum similar and different? And the last question, how does the number of carbon atoms within its molecule relate to its viscosity and boiling point? So they have some really good thought questions here, and after reading these over, I generally decide whether this will be a conversation question or whether it will be a homework question. And you can get a pretty good idea of where the kids are and what their understandings are using this concept check as a homework question, if you're so inclined. But they're pretty good questions for getting an understanding of how they're interpreting all these new ideas. Examining petroleum's molecules and hydrocarbon boiling points. Again, following the same theme through. What is special about this petroleum, and why is it that some of these molecules boil so easily at such a low temperature, and others are very slow to boil and have to have a much higher temperature? And we introduce the idea of intermolecular forces in section A7, and follow it up with developing skills of hydrocarbon boiling points. I assign this for homework, and then we have to talk it over, because some of the students don't grasp the idea that some materials boil at very low temperatures, and when they think of boiling, they think of the tea kettle or of a pot of boiling water. So I think in many ways this is sort of a reality check for chemistry students. And some of the kids do have a hard time with it, but it really opens up conversation possibilities. There is, these questions are really well organized, and they will be asked to evaluate whether or not the table on page 283, which is alphabetical, is a good way to list these materials to determine what their molecular formulas are or what their boiling temperatures are. And then they'll be asked to come up with another way of organizing them. And I find this to be a really good activity for the students. This is a homework activity for me, and then we go over it in class and have pretty good results. Once again, because it's in the ChemCom way, it's given in degrees Celsius. So we have an opportunity to talk about this temperature scale once again, and that 0 degrees Celsius and 32 degrees Fahrenheit are about the same temperature. They are the same temperature, whereas 98.6 is body temperature, average body temperature, and 37.5 degrees Celsius is body temperature. So the students look at this and they start to realize that some of these petrochemicals, some of these hydrocarbons boil at very low and very high temperatures, and they will have the opportunity to see that the molecule size has something to do with this. Modeling matter follows, and I think that whoever wrote this originally should get a Nobel Prize, because this is absolutely stupendous. If you are lucky enough to have models in your classroom, you will be amazed at how well this goes. I put students into groups, and we have the ball and stick models, and I have them work in as few as possible partners if I have enough models to go around the classroom. Then I introduce this, and then I follow. I also use the teacher resource materials here, and I print this out, and I have the students turn it in, and I tell them they must answer each and every question. They cannot skip a line or a word, and they will be amazed at the amount of knowledge they will come away with. This is actually, they're going to be asked to build and understand alkanes, which are the single bonded first series of hydrocarbons, and they will be asked to diagram them in sort of a 3D way, as well as just a straight model, connecting these molecular formulas with the two-dimensional diagrams that they're going to generate really gives them insights. They'll build, I build the first one, I build methane and hold it up, and we talk about its shape. We have an opportunity to talk about why the molecules looks the way it does, why are the hydrogens in the positions that they're in, and also I think something that's a big plus for this textbook, the fact that this is matter. These little atoms are what makes the world, and they're three-dimensional, just like we are. Students can't walk out of there thinking that atoms are flat on a page. They're three-dimensional. They take up space, they occupy space, and they have a volume. And that they're very, very predictable as to how they're going to come out. There is a diagram, a table on page 286, and before I start, I tell the kids that they have to be able to memorize this, and they're going to have to write all of the names, the total carbons. I don't assign boiling points, but molecular formulas and condensed formulas. That there will be a quiz, and that they have to be able to do all these. Once they have worked this through, it is amazing that they all have a handle on this, and almost 100%. I suppose some of the learning disabled kids have difficulties, but most of even those kids, because it's so obvious, and it's so friendly, and it's so tactile that they've built these models. that they have very good results with this activity. Barb.
Well, one thing that I use, I don't have the larger models. I have, because it's very cheap to get great big boxes of these minute models. They're like little minute models, tiny little things. And I can put them in sandwich bags. I can put a whole kit together, so each group gets a kit. And I ask them to draw and label everything that they build, and then following that, answer questions that pertain to that. So I've got some drawings along with the questions. I think that was the main things I could add to that, Linda.
Yeah, I think it works really well. It's really pretty good. Following this, and this takes a whole period. This takes a goodly amount of time. I walk around the room and make sure they're not building dogs out of their models, because that's the first thing some first group will build dogs or monsters or something. So I would recommend you be walking around and making sure that they are keeping their nose to the grindstone with this. Developing skills, trends in alkane boiling points. Again, this is a paper and pencil task. They're going to make a graph once again, and I have to say, students that take ChemCom can graph. They can graph and they can read graphs, and I don't allow them to do them on computers. I make them draw the graphs, and by golly, by this time of the year, there are very few opportunities for me to make a correction. They're also going to introduce, again, this has come up before, but we're going to talk about extrapolating. And again, we're following through with alkane boiling points. This is a homework assignment in my classroom, and then we go over it in class. It really does help with any of these graphs if you have access to a projector to prepare the correct answer, and although it's given in the book, project it for the students to see. If not, perhaps a big sheet of paper, or even on a whiteboard, so the students can see what they're supposed to be looking at. I find this works really well, and this theme just falls straight through here. Barb, anything?
Well, just that, it's kind of interesting that the extrapolation that you just mentioned, because my students have just finished the temperature volume lab from the last unit, and
yes,
they were extrapolating to absolute zero. So here we have the spiraling effect where we keep coming back and showing this same material again, as students need to know it in a different context.
Yes, absolutely. This, again, we're going to visit Concept Check 3. They're asked to respond to some questions that they should know answers to. And then finally, a new vocabulary word: what is an isomer? Again, you will have to tailor this to your particular classroom. These can be homework, or they could just be conversation questions. At this point in the year, sometimes you want to put them into groups. Sometimes if I am running short on time, I will have one group do one question and then report out. Every group will then report out with an answer. And let's see. Next we have intermolecular forces. Once again, are going to come up. Introducing polar molecules here. Pretty straightforward. You could bring in London dispersion forces or dipole-dipole interactions. I pretty much just hit the bare bones on this particular activity. We will get into the polarity of the water molecule in the last unit, but it's brought up here and it's well demonstrated. Barb, do you spend a lot of time on A11?
No.
Yeah.
Just basically what you said, because we're going to be looking at it again and again and again.
So it's going to be an introduction of a concept, but we're really not going to spend more than just maybe a few minutes on it. Then we move back into modeling matter. the alkane isomers. At this point, after having done the previous model building activity, the students sort of get right into this. If you're using model kits, you are going to want to make sure to remind the students not to use the springs for their model bonds, only to use the sticks, and to kindly remember that the bonds are pretty much equal bonds, so if they build a molecule, they should use all the same size little bond sticks. There is a diagram that is shown right here on this page of the presentation. We talk about it, and I have the kids explain this out to the class, and it really works well. I mean it's pretty good, as is the follow-up, which is boiling points of alkanes, and again we're following through with that theme of boiling points. Barb, anything here?
Well, only that these models they've built work so nicely here because they can see two straight-chained hydrocarbons have a lot more surface area where they're touching, and then when you put a branch on it, it just pushes them away. So they pick that up pretty quickly.
Yes. And then we move on to another chem quandary. This one is pretty interesting, and now we're going to take a look at the chemistry that we have been talking about, and we're going to ask, how does this impact in the real world? And this brings up different kinds of fuels that are used in different parts of the U.S. In Alaska, when it's very, very cold in the wintertime, they have to have a different molecular concoction than they do, say, in Florida in the summertime when it could get very, very hot. So we need to control and build the proper molecular structures for the fuels. And the kids may be aware of the fact that in the spring and in the fall, gasoline gets really expensive. In our school, the kids are starting to get their driver's license, so they're starting to be buying gasoline. And they notice that the gasoline prices go up in the spring and they change again in the fall because the refineries have to reset their systems to produce the proper kind of gasoline that will adapt to the environment. It gets really hot in the summer and really cold in the winter. I love this one. We spend probably 15 minutes on it. Nothing really much longer. Making decisions is next.
Well, I could let me just interject one thing. Our governor has just signed a bill to release some of the winter gasoline a little bit sooner because the gas prices are, $5, almost $5 a gallon or more. And so he's releasing some of the cheaper blend now, about a month early, just to bring the prices down a bit.
Okay. Wherever you are, you will find that this is right on your newspaper's front section. So bring that into your classroom and make the kids make those connections. The last part of Section A is who has the oil. This really becomes a group project. In my classroom, I have my lab group stay together for the whole unit. This is their first actual work for their unit project, for their commercial that they're going to design. And this will give them lots of information that they should consider when they are making their commercial and deciding on what kind of fuel their vehicle will have. This is also really an opportunity to bring up again what's going on in the world in current science. What's going on with the needs of the various countries for petroleum. Everybody wants a car in China just like we have. Well, where are they going to get the petroleum? Are we going to open up our Arctic National Wildlife Refuge? Well, I think that there's some possibility, and I think that's actually going to happen. Are we going to expand offshore oil drilling? This is a really good activity. It's a student activity. I put them into their groups. They all write the answers down, and I would advise you to have every student write the answers down. Otherwise, when they start working on their final project, if the kid who wrote it down for the whole group isn't there, then they can't do their work. So my advice as a veteran on this would be to have every group, every student either keep a track of what their answers are for these various questions, or leave the answers in the classroom. I like these activities, and if you've never done ChemCom before, you may be tempted to skip it, but they really put it all together for the kids, and they will put it all together at the end of the unit. Barb?
Well, actually, I keep them.
Well.
My groups work on them, and just like you said, I think I learned the first time I was teaching ChemCom that it works best to keep the same group all the way through the unit. And so I do have the groups work. They do it on a single piece of paper. That gives me a chance. I collect them at the end of the class period, and gives me a chance to go back and evaluate and identify any misconceptions. But then I have a little file for each group, and I keep that. They're numbered, and I just keep their papers in that file. And then when they're working on subsequent various different making decisions and so forth, then they can come back and get their papers as they need them, and particularly for the final project.
Yeah, they need this to do the final project, and you just don't want to skip it.
But you definitely don't want to have one student keep it and then they're absent the day they need it. So.
Right, or they lose it or whatever.
Yeah.
This brings us to the end of what is petroleum, and we now have section summary questions, and there are different ways to handle this. You can assign these as you go through the unit, you know, as they pertain to the topics that you are dealing with in class. In each above each of the groups of questions, there is in orange a box with a review of the concepts. My students find that to be very helpful, and I find these questions to be a wonderful review. I assign these, again, I do it differently in every unit, but most of this year I have been assigning them as we go, and then before a quiz, at the end of each section I give a quiz. We go over these for review, and they're wonderful questions. They're easy questions and hard questions and thought-provoking questions, and I highly encourage you to at least try them. You can collect them and grade them, or you can just hear what the kids are saying. I do look at them. I do collect them and look at them, and it gives me an idea of where they are before we take the quiz. Sometimes I look at them while they're taking the quiz, and how well they've done the questions seems to be right in line with how they score on the quiz. Barbara?
I don't really have anything to add to this, I don't think, except that there is a final section summary question that has a green band to it, and that one they use for a section reflection that they write.
Yeah. Before you leave each section, you're going to find on the very last page of the section summary questions a leading question that sort of wraps things up where you've been and where you're going. So I again would advise you, it does give the kids, it does remind the kids of what they learned. And that brings us on to section B, building materials. Now we're going to look at the next two sections are going to be focusing on building with petroleum or burning petroleum. Students don't really get that petroleum is an incredible building source for just about any kind of material that we use. And again, we've sort of dwelt on this. Again, goals, I read these together with the kids and I refer them back to them later in the unit. We will hit another concept check, and you're going to be introduced here to some of the places that we'll be going in this section. B1, I think I hit this. Let's see. Yeah, there. B1, life cycle of a polymer. In the teacher's manual, if you look at page 3XIV, there is a list that's a guide for all the polymers that the students will be looking at, all this that they'll be using. I only use the first 6. I collect examples of all the different polymers. I put the kids into, I actually have 6 lab groups, and each lab group will explore properties, uses of that they can equate with their particular polymer. I put these in a box at the end of the unit and save them for the next year. I keep them all clean because it's really, you don't want to wait till you begin Unit B1 to start looking for your polymers. This is a short making decisions, at the most 1 period, but I think that it brings back what the carbon footprint is. What do we do with the polymers when we're finished with them? Are any of these recyclable? If so, how do we recycle them? Can we reuse them? In this new edition 6E, I like this. It's new, and I like it, and I'm sorry I haven't used it before. I didn't think of it myself. Barb?
Well, the only thing that I do is I have the kids bring in the polymers, and they are assigned according to what group number they have. I have usually 11 or 12 groups in my class because our class size is pretty large, and so there has to be some double up. But I do assign this right at the beginning of section A, so that they have plenty of time to look for things that have the triangle that corresponds to their group number. So then I have baskets around the room, and they just come in and they put them in when they find things.
Okay, sometimes I can't depend on my kids to come through with the polymers, so I have backup. But I find it to be a good activity. And chemical bonding, again, we've got another picture from Scientific American. We're going to introduce once more the molecular structure and the atomic structure of the atom. We've talked a little bit about atoms before, but now we're going to talk about shells. In this section, we're going to introduce covalent bonding and what that means. We're going to introduce the idea of valence electrons. I have talked about these before, but not in detail. And this is going to lead us to conversation about single covalent bonds and, of course, Lewis dot structures. And this will be followed up by a developing skills. So you have 3 or 4 pages here of lots and lots of information, and then you're going to follow it with a developing skills. And you'll have to model this for the students. I always answer when we get to B3, we do the first couple questions together, and I put the answers on the I project them. Either I project them onto a screen, or I do them at the front of the class on the chalkboard or the whiteboard, and we diagram the where the electrons are. Now they've built models. They have built models of this, and that is shown here. And now they're going to understand why Lewis got the Nobel Prize for this wonderful structural piece that he has developed. This is going to allow the students to transfer that knowledge that they got hands-on onto a two-dimensional surface. Barb?
I think you've done a nice job on this.
Okay.
Thank you.
Again, we have another concept check. Polymers, why are they so versatile? They won't have a clue. They probably will be in amaze that they didn't know this after we have done it. And with this part of the unit, I go pretty fast. This is we're going to introduce double covalent bonds, now we're going to get into petrochemicals, what they are. The kids are ready to see these, look at these, and understand what they are. Nice pictures in the textbook as well as these questions. We're going to talk about addition polymers, and that they're made with the most wonderful chemical label of all. They come from addition reactions. So a little bit of an introduction here also to some of the cyclic molecules, and this is going to lead right in once again to a modeling matter. And this one we do together because the kids have been drawing models. And for these answers, now we're going to ask the kids to think about the various molecules and polymers, and think instead of what each particular atom and each particular compound looks like, what the shape of the whole thing is. And if you look at the teacher's manual, they have drawn some diagrams of what these giant molecules look like. The kids are going to get a step up. Okay, now we've looked at these molecules atom for atom, but instead, because they're so huge, we have to look at them in a different way. And instead of drawing each little atom like you see here with cross-linking, we're just going to show the whole, the shape of the whole giant molecule. I do this, and I think my kids understand it. I was worried that they would have a hard time going from the diagrams that we have been drawing to the big picture. But I think they get it. So I love this particular one. We work a couple of these together, and then I have them do the last group for homework. And then I do collect those and grade them. They're asked to do what straight molecules are going to look like. At this point, the textbook, the teacher's guide, I think it's at this point they offer you some different demonstration ideas. And I always do the Ziploc bag full of water with a very sharp pencil, and I poke it through above, holding the bag above somebody's head, and it doesn't leak. And it has to do with the structure of the molecules. The molecular structure is reflected at the macroscopic level. So just making connections there. There's also, you can do a styrofoam demonstration, putting pieces of styrofoam into an acetone beaker, and it just absorbs and absorbs and absorbs. Again, this is the real world of polymers. And I suppose we could spend weeks and weeks and weeks on this, and instead we're just going to get a brief introduction to it. Barb?
Well, the only thing that I do here is I cook spaghetti for them, the pasta, and then we look at the strands all muddled up, and then we see how nicely we can put them with cross-linking branches and cross-linking and so forth.
Wonderful, wonderful. From here we're going to move on to beyond the alkanes, and again the builder molecules. They're going to be introduced to unsaturated hydrocarbons, saturated hydrocarbons, and introduced to the next family of the hydrocarbons, the alkenes. So we'll now be talking about double bonds, and in this section B6, it's just an introduction in the terms vocabulary. It's going to tell us about also hydrogen bonds, and then we'll move into another modeling matter. And again, the kids are going to be building some models here, and they get to use the springs for the double bonds. And we spend a little bit of time talking about the fact that you can't use single bonds if you're going to, and we talk about the formulas. And if you have a formula, for example, for ethene, we can draw the Lewis dot structure, we can draw the structural formula, but when you build it in a three-dimensional model, using a three-dimensional model, you have to use springs because those bonds are very different. The double bonds are very different, and we'll also then go ahead and introduce the alkynes. And further in this particular section, we will also pull in some oxygen into the structures and introduce dimers. The students are ready for this. They have built before, and they are ready for this, and they pretty much, I think they understand it and can do this pretty much on their own. Barb?
I don't think I have anything to add to that.
Okay. Come back to a concept check. Again, we're going to talk about, this is leading us into functional groups. And in B8 and B9, again, we're going to talk about ring molecules, benzene, nice pictures in the book showing different shapes. We're also going to talk about aromatic compounds, and the reading material is very straightforward. We're going to be introducing several functional groups and focusing especially on esters, which we will produce in the next investigating matter, the condensation lab. This works very well. There are some tips in the teacher's manual for you when you're working with this. I keep the catalyst, the sulfuric acid, at my desk. The students have to come up and get the catalyst under my watchful eye. Sometimes the ester may not smell as strongly as it might. You could add a drop of water, and sometimes that allows it to be more recognizable. I have really, really good luck with this one, and the kids always get it. I recommend that you make sure your test tubes are really clean, though, before you start, as you're going to be using an alcohol and an acid, and then the sulfuric acid for your catalyst. Also, only with the water bath and the hot plate. Barb?
Once the students have set up everything, then I come around, I share your concern about the acid, and I have such large classes that I come around, and when they're all set up and ready to go, then I put, just using a Burrell pipette, I put a couple of drops of acid in their mixture. I also put together a lot of different combinations of alcohols and acids, so that students get that form different esters in the class, and they can compare those. And then later on, I ask them to write the equations for their different esters.
There are also kits you could purchase. They have different scents. The kids like this one. It's easy. You can do it in a very short amount of time. I collect the test tubes and clean them out because I have concerns about the acid, so I do clean this one up. I don't do that for very many. Okay. Condensation polymers, again, this is in B11. We're going to talk more about what these are, following up with making decisions, and in this making decisions, now we've talked in this whole of Unit 3B, we've talked about the builder molecules. Now the kids are going to be asked to think about where the builder molecules are used in designing a car. And this is, again, you need to make sure that the students have access to this information later, because this will be important. This is, they're going to be asked to look back at the commercial and compare what the commercial said with, at the very beginning of the unit, with the TLCP car, and if what was said was all true, if it's possible, and also other ways that they can adapt and understand what these builder molecules do. And my advice is do what Barbara does and hang on to them, or make sure that the kids all have a copy. Barb, anything?
Nothing, thank you.
Okay. That brings us to Section B, Summary. And again, we've got the boxes that remind us of what has been taught. Again, for these, I assign these questions as we go through the unit because I make them do almost all of them, I think. And it's too much to do for one night's homework. I suppose if you're going to be out, it would be a good thing for students to handle while you're gone, but it's really, there's a lot of questions, and they're good quality questions. So.
And since they're all broken down in the section summary with the, by different sections as they've studied it, I will make 2 or 3 different sets of questions and just assign some of them that are due on one day and some of them that are due maybe 2 or 3 days later and so forth.
Yeah, it works out. You definitely need to look at them, but there's an awful lot of, if the students did them all, it would be an awful lot of time for one assignment. We have also got our final question here. Why are carbon-based molecules so versatile as chemical building blocks? And again, this is a conversation stop-off for us. And the kids find that they've learned quite a bit and that these are not magical words anymore. Then leading after that, we have Chemistry at Work, questions and answers. This is really a very good set for these high school kids because they have all heard about these oil spills, and here they're getting a chemist at work, and questions and answers. We read these together in class, and they are quite the conversation generators. They especially are intrigued with the bird, so I advise don't skip this. It just gives more depth to their understanding and an insight into what some chemists do. It's not what you would think a chemist does if you are in the 10th or 11th grade. Barb?
I don't have anything to add to that either. Thank you.
Alrighty. So that brings us to Section C. Petroleum is an energy resource. So in the last section, we talked about building things from petroleum. And here, now we're going to think about what the original, probably their original ideas about petroleum were. It's gasoline. I love this because it talks about the history of petroleum. And that's Drake's Well there, the picture, which is in my part of the world over here. I'm in Illinois. It's across Lake Michigan and over at the bottom of Lake Erie. So this, again, is an introduction of what we're going to cover. And the goals are found. Again, you can assign these. If I assign them, the kids don't read them, so we read them together. Followed up by a modeling concept check, and this gives them a preview of what we're going to do in this unit. The very first laboratory activity that we're going to tackle, investigating matter, comparing fuels. In my classroom, we use 2 different fuels. We use candle wax, and I have alcohol candles from the biology lab. Other people use various other fuels. Those are the 2 that I use. Notice the diagram here. They're showing a stirring rod. I start collecting cans about at unit when I get into B, because you're going to need cans to make these calorimeters, and you need to rinse them out and let them dry out for a little bit so that they're fairly clean. You can use a pencil or you can use a stirring rod. You don't want to take off the flip top, and they are going to do this repeatedly. So they will get to be pretty good at setting up a calorimeter and I hope understanding what's going on. They're going to compare fuels in this particular lab. And this is a qualitative rather than a quantitative study. So it's a good beginning for where we're going with the energy. Barb?
Well, you know, Linda, I thoroughly agree with you, but I have a time pressure. Our kids take their state tests in April.
Oh.
In the second week of April, and this is very, very important to the administrators and everybody. So I have to cut somewhere, and I know that coming up in just a couple more slides, there is the burning of a candle and the calculations. Yep. So I just have to skip this and just move right on.
Well, and that's very doable, because this really is sort of an introduction to lab, and it is one that I could see someone actually cutting out. We are going to move forward then, and we're going to talk about energy, and we're going to follow energy. We're going to look at endothermic and exothermic reactions, the law of conservation of matter. We're going to take a look at these energy diagrams. These really help the kids understand what happens in a chemical reaction. We're going to introduce potential and kinetic energy, thermal energy, and the kids come back and tell me that these are on the tests that they take, their ACT tests and their plan tests. So I'm pretty happy. I think the book does a good job of it. I definitely wouldn't skip past it, and I would make sure that they understand the diagrams. I actually copy the diagrams and give them to them on quizzes and make them explain to me, where is the energy flow? How is the energy flowing? Is this exothermic or endothermic? What's happening to the molecules? Are they all the same number of atoms over here in the reactants as there are in the product? So good. I think it's really very, very clear. It's very clear to the kids. There are lots more diagrams in the textbook in this particular section.
I could just mention one thing. I feel very strongly about starting a new unit with some lab work. So what I do, prefacing this since I've skipped the lab, is I have the kids take test tubes and put a little bit of ammonium chloride in one with some water, and the others I have some road salt, and they put that in another one and put a little water in, and then I ask them, you know, to explain particularly something like, well, this gets cold, the ammonium chloride, and where do you think that heat came from? That reaction needed heat. Well, most of them figure out it came out of their hands and left their hands feeling cold. So that's kind of a nice introduction to this,
yes.
The diagram.
Yep. Yes. All right. Moving on, we then follow this up with developing skills, energy and chemical reactions. Some questions. They'll be asked to make some diagrams, draw some electron dot pictures, and hopefully explain what was going on in that last section. And this is followed up by Barb's favorite, the combustion lab. The students are going to combust paraffin wax, and then they're going to use their setup, their calorimeter, and try to calculate how much energy was absorbed by the water in the can. The directions are really clear. This lab is a lab that I think it's really a long lab, in that you need to really explain to the students what is going on. I put the reaction on the board. We talk about where the energy is, where's the energy coming from, what's happening to the paraffin, what is produced, where does the carbon dioxide come from, where does the water come from, and where is the energy that's released, and what kind of energy is released. The students will prepare their calculations by following what they have done earlier in the earlier lab activity in my class, and then when we are all done in the textbook, there is a sample problem that helps them to calculate the amount of thermal energy that must have been added to the water to raise the temperature. I put up fake data that I have prepared, and we work through this. Some years, depending on the level of students, if I have students that struggle with anything mathematical, I give them a copy of it, and I make them fill in the numbers as we calculate them so that they have practice before they actually take their own data. This is a lab where I have the lab groups work on generating their data. Again, I get from the teacher resource manual, I get a copy, and then I can collect it and check the kids what they get from their calculations. The follow-up questions, the reflecting on the investigation, I think these are just great, and I think this is really a terrific and can be a very challenging lab. Barb?
I don't think I have anything to add.
You're going to introduce, molar heat of combustion, thermal heat of combustion, followed by and then we'll go into heats of combustion, using heats of combustion. Students will be making calculations again. They're going to be writing chemical equations for the combustion of these various molecules, and I find that they are very competent at doing it by this point. Again, if you don't think that they're getting it, then work through these using examples and then have the students. I don't think they can do it just out. You've got to show them how. The next section is a modeling matter, and it is incomplete combustion. Introduces the very important idea of limiting reactants. Again, I work through these. We do the first couple together as a class, and then I put them into their groups, and they will come up with diagrams. Something that you might want to try, if you have the white shower boards and dry erase markers, I think the students working in groups are able to puzzle these out with a community whiteboard. I give a whiteboard to every 3 or 4 kids and a marker, and they have to puzzle these out and pass the whiteboard around until they figure out an answer that they're all satisfied with. You're talking now about moles as moles of elements as well as diagrams. So this gets to be it can be pretty difficult. Barb?
I do something basically the same way I do. I have small whiteboards, and I actually assign to different groups are responsible for different questions, and then to show that and explain it to the class.
Yeah. The carbon cycle is next, and this is introducing how cycles impact all of the world. We're going to talk about the carbon cycle real quickly, and this is really going to lead us to a little more understanding about carbon dioxide in the atmosphere. It's your opportunity to, in a non-political way, bring up carbon dioxide levels in the atmosphere. We're following the science. We're not making any kind of, I know some teachers have a problem with this because parents complain, but you're following the science. There's no opinions here. This is the data, and it has followed. I have had very good luck with this, and I have had very few problems, but I know some people have. Barb?
I thoroughly agree with you. I think as long as you look at science, and we want students to use data to make decisions, and just look at the data, and you just don't bring in any of your own political views or biases along with it, and I think you're fine with it.
Yep. And this is followed by greenhouse gases, global changes, and responses to global change. This is, again, it's just a follow-up, and there's lots of information in the book with some lovely graphs and pictures, and it is then followed by fuels for transportation, and now we're getting into where we're going to be going in the next section. Again, making decisions, I don't skip this. I make the kids work on it in their groups that have been assigned for the whole unit. And that brings us again to a section summary. Questions for review and an idea of where we've come, the energy we've talked about, heats of combustion, conservation, the carbon cycle, global climate change, and the carbon footprint, and what are the benefits and consequences of burning. So now we've talked about burning and building with petroleum, and now in section D we're going to get back to alternatives to petroleum. This is something that I find my students are very tuned into. Alternate energy sources, solar power. We actually have a solar panel on our roof. The kids are interested in that. They see the wind power. In some parts of the country they have geothermal or hydro power. So we're going to follow up in this section with potential for the future, as well as talking about some things like octane rating, biodiesels. We're going to make some biodiesel. We have a concept check. What is petroleum? That was from section A. Number 3, you're going to find some interesting ideas here, and that's what we're going to be learning about in this section. D1, energy again, past, present, and future. Turn the page. Okay. Past, present, and future, cellular respiration, and biomolecules. If your students have had biology, this will be familiar. In my school, we've flipped the curriculum, and we have biology after chemistry because we find the students do so much better with a little chemistry under their belt. So you're going to give them, in the case that you have biology later, they're going to get an introduction to photosynthesis and respiration, and what fuels are and what different kinds of fuels are. This particular section talks about the past, the present, and the future, and it also emphasizes that all the fuels on the earth are really basically solar powered. Section D3 and D4, we are going to talk about efficiency, energy efficiency, and vehicles, and transmitting or changing potential energy from the gasoline into energy to run the radio and the lights. Students will be asked to think about this and to calculate fuel efficiency along with their burning of petroleum. Energy efficiency is, I think, a big idea that is going to come out of this, and then we'll move to conversion of energy also. These are arithmetic problems in D4. I find that I do have to demonstrate these. Once they remember what they're doing, it works out, but it's I think these are pretty important, and I never skip these. Barb?
Likewise, and my students are always just amazed at the efficiency that only 25 units, only a quarter of this gallon of gasoline actually they use to, to tool around with. The rest of it is all the other stuff. So yes, they're surprised, and this is a good, this exercise is a good reinforcement of using canceling units, factor label method for
yes
kids.
Yeah, and using evidence to come up with what they're saying. Concept check, again, reminding the kids of what they've learned, and reviewing where we've been. It's going to go back and talk about some of the fractions. D5, altering fuels and oxygenating fuels. Again, we're going to introduce another process that happens at the refinery. We're going to talk about cracking and what cracking is and why we crack. And I think this emphasizes that chemists are essential to putting that gallon of gasoline in the cars that we're driving around. So we talk about gasoline, there's a little bit of history about the lead that was added previously. They talk about octane rating. We're going to lead into a conversation that's ever so brief about isomerization of hydrocarbons. Again, we're going to talk about another kind of a catalyst, heat as a catalyst, oxygenated fuels, and leading to a conversation that will come up in our next lab, and that is biofuels. But before we get there, we're going to do a making decision on oxygenated fuels. In this section, D6, which I think we skipped over here real quickly, the kids are going to be asked to do some calculations in kilojoules and grams, so it's just using information and understandings that they have gotten before. D7, alternate fuels and energy sources. This is going to talk about some of these the fuels that are available out there. Oil shale and fracking is going to be, you'll have to bring that in. Coal liquefaction, petroleum substitutes, and other strategies for getting alternate fuels and energy sources. And this leads us to a discussion, or to our lab, our investigating matter, synthesizing biodiesel. For this, you're going to want to, there's a picture here of the tea light. You take the tea light out and remove the paraffin and put the little wick back in, and there's your chamber that you're going to use to test your biodiesel. I have used vegetable oil and canola. They both seem to work pretty well. I use small water bottles as the chamber for generating. The kids need to have some sort of a container that has a lid that you can seal it up when you put your chemicals in and shake for 10 minutes. You're going to be using some vegetable oil and also KOH, and that's pretty caustic, so you want to make sure that this is sealed up. One teacher I know collected a bunch of baby food bottles, and that worked pretty well. I find that the small size water bottles works really well, and you're not left with a whole lot of biodiesel at the end. Although I collected all the biodiesel and put it in an oil candle and burned it for a while.
We usually let it sit overnight once you've salted it,
Yes.
and it seems that it separates really well. And there again, anytime I can take a lab and spread it over into a second day, I like doing that so that they can think about it one night and then they're coming back to work on it again.
I think I spend 3 days on this. I think I let it go for 3 days. We don't burn it till the third day. But it's all in the news, and you'll find the kids are going to be interested in this. And that brings us to biodiesel as a petroleum substitute, and this making decisions is very thought-provoking. So again, I put the kids into groups, and this goes into their packet for their final project. And this leads us to yet concept check 11, and this last question here, list types of alternate fuels, that's going to really be sort of the foundation for where we're going to go for putting it all together. And in section D10, there is just a plethora of information that the kids should read through and decide then, after I make this a requirement that they read it all, and then they come back to their groups and decide on what type of a vehicle they want to have for their commercial. And I try to get the kids to split these up so that everybody doesn't do CNG or fuel cell or whatever. I limit it to the alternative fuels that the book offers. You will have to make that decision for yourself. There are other alternate fuels that are possible, but I limit it to just the ones that are in the textbook. Barbara, how do you handle this?
I do that the same way, and I write these four that you see up there in the first bullet on little slips of paper, and then I ask the kids to rank them in order of their preference, because I don't want everybody doing the same one.
Right.
So then I can sort of, check their preferences, and of course there are going to be some duplications, but I kind of spread it out so that all of them are represented.
Section D doesn't take that much time compared to Section A, B, and C. Section D goes pretty quickly. Making decisions, evaluating alternative fuels. This is the final step before we get to the unit project. And again, we're going to be followed by some section summary questions, and then we will get into the PIOT, the unit project. I give a unit test. I give a quiz, at least one quiz per section, A, B, C, and D, and then I give a unit test. Sometimes I allow the students to have a couple of days after the test to work in class on their project. Sometimes I give them a couple of days before the unit test. Whatever seems to work. It's never the same 2 years in a row. You will find your students love this project. They are so technologically able, and we get wonderful commercials. I require them to make them so that they will play on my computer, which happens to be a PC, and I also require the students, when they do their commercial, to prepare a copy for every person in the group, because our school keeps portfolios, and this commercial then with the attached write-up that goes with it goes into everyone's portfolio. Barbara.
Well, I do require the written part also. I have them use that, what you showed right at the very beginning of the unit, where they have the 2-column format, and that helps them guide and think about it, so the commercial doesn't just become a big bunch of fun as they're, showing cars racing around. And so they have to think that out first, and that typed copy with at least sketches of what their pictures and so forth are going to be. So they have sound and pictures on one column, and then they have their text on the other column. So that's required, as well as the what they put together, a PowerPoint or DVD or whatever they put together.
FYI, for your information, there's also in the teacher resource materials suggestions for rubrics for the PIOTs, and you can adapt them to suit however you would like to grade your students' projects. There are also other ancillaries that are available. There is a test bank. There are teacher CDs and websites that you can use to back yourself up with these. My students love this unit, and we do this in about 1 quarter in my school. I have short periods, and so, but it does take 1 quarter. And that is all that I have. Barbara, do you have any final comments?
No. It was fun working with you, Linda.
Oh, Barbara, my hero. And Michael, we're going to give it back to you. I'm sorry we've taken so long, but we just have so much to say about this wonderful unit.
Great information. This has been awesome. Again, I want to thank you, Linda, and thank you, Barbara, very much for all your wonderful insights. I will pause for a moment to see if anybody has any questions before we stop the recording, and then we will close down. So does anybody have any questions? I don't see any questions, so again, thank you very much, Linda. Thank you very much, Barbara. I am going to stop the recording now. Thank you all for participating.